Hi. So we have learned the method of comparison of fractions when either their denominators are same or their numerators are same. So just to revise this, when we have same denominators like 1 by 4, 2 by 4 or 3 by 4, how do we compare? We compare only the numerators. So the fraction which has lowest numerator is the smallest, right? Like 1 by 4 is smaller than 2 by 4 and 2 by 4 will be smaller than 3 by 4, right? So this is the method when we have same denominators of all the fractions, right? So the fraction which has bigger number in the numerator actually holds the bigger value, and the fraction which has smaller number as numerator, like this one has 1 as numerator, this is smaller than 3 by 4, right? And then we had learned one more method where we had same numerators, like we had 1 by 4, 1 by 2, 1 by 3 or 1 by 5, right? Here all the fractions have 1 as their numerator, but all the fractions have different numbers as their denominators, right? So the biggest fraction will have the smallest number as denominator, right? Here this fraction is the largest fraction. Why? Because this is talking about one part out of two equal parts. Here we are talking about one part out of three equal parts, right? So since here we have made three equal divisions and here we had made only two equal divisions, so in this case each division will be smaller, each portion will be smaller, right? So when we have same numerator and different denominators, the fraction which has the lowest denominator, like in this case 1 by 2, will be the biggest or the largest, and the fraction which has biggest denominator like 1 by 5, this will be smallest in the value, right? And now let's talk about the generalized method. So in the generalized method, we will be tackling fractions which neither have same denominator nor same numerator. So let's talk about fractions like 1 by 4, then 3 by 5, and then let's talk about 1 by 2. So here we have three fractions, right? And definitely we can't say anything about them because neither they have same numerator nor they have same denominator. Yes, 1 by 4 and 1 by 2 have the same numerator, but here we have 3 by 5 also, right? So among 1 by 2 and 1 by 4, we can say that 1 by 2 is bigger than 1 by 4, right? But where does this 3 by 5 lies? We cannot say anything about that. So how to solve these kind of situations? So here we are going to do certain things. I'm going to write fractions like this. We had 1 by 4, then we have 3 by 5, and then we have 1 by 2, right? So what we do here is we find the equivalent fractions of all the fractions, and then we note down the fractions, equivalent fractions of these fractions where all the denominators are same, right? So 1 by 4 can be written as, if I multiply both the numerators and denominator by 2, we will get 2 by 8. And if I multiply both numerator and denominator by 3, we will get 3 ones are 3 and 3 fours are 12. And if I multiply both numerator and denominator by 4, we will get 4 ones are 4, 4 fours are 16, and if I multiply by 5, we will get 5 ones are 5, 5 fours are 20, and if I multiply by 6, we will get 6 ones are 6, 6 fours are 24, and if by 7, we will get 7 by 28, right? And now let's repeat the same procedure with second fraction also. So here if I multiply both numerator and denominator by 2, we will get 3 2s are 6, 5 2s are 10. And if I multiply by 3, we'll get 3 3s are 9, 5 3s are 15. And if I multiply it by 4, we are going to get 4 3s are 12, 4 5s are 20. Right? And if I multiply it by 5, we are going to get 5 3s are 15 and 5 5s are 25. And if I multiply it by 6, we are going to get 6 3s are 18 and 6 5s are 30. So here we have written till 28. Here we have written till 30 because we are not getting 28 in between. But one good thing is this fraction has denominator as 20, and here also we have got one fraction which has denominator as 20. So now 1 by 4 and 3 by 5 can be compared, right? Let's do the same procedure for 1 by 2 also. So if I multiply 1 by 2 in the numerator and 2 in the denominator, we will get 2 by 4. And if I multiply it by 3, we'll get 3 by 6. If I multiply it by 4, we are going to get 4 by 8. If I multiply it by 5, we'll get 5 by 10, 6 by 12, 7 by 14, 8 by 16, 9 by 18. And if I multiply by 10, we are going to get 10 by 20. So here also we have got one fraction with denominator 20. So let's not write the equivalent fractions anymore. And now we can perform comparison, right? So here we have three fractions. All three of them have 20 as denominator. And how we found them? We have found them by writing the equivalent fractions of 1 by 4, 3 by 5 and 1 by 2, right? So 1 by 4 is actually equivalent to 5 by 20 and 3 by 5 is equivalent to 12 by 20 and 1 by 2 is equivalent to 10 by 20, right? And now I think these three can be compared. And how do we compare when we have same denominator? We directly compare their numerators, and the fraction with bigger numerator carries the bigger value and the fraction with smaller numerator carries the smaller value. So if I write them in ascending order, the smallest one is 5 by 20 and then we have 10 by 20 and this 10 by 20 is smaller than 12 by 20, right? Yes. And if I write the original fractions for all these equivalent fractions, our relation will be 5 by 20 is equivalent to 1 by 4 and 10 by 20 is equivalent to 1 by 2 and 12 by 20 is equivalent to 3 by 5. So actually 3 by 5 is the biggest fraction and this is the fractions in the ascending order, right? So how we did this? We have written their equivalent fractions till we got same number as their denominators and then we have compared their numerators, right? So this is slightly longer method. We have a shorter method for this and in that we actually find the LCM and then we reach to these equivalent fractions directly, right? So I'm going to copy this over here and then we are going to learn the method using LCM. So now I'll remove all this. So now we are going to find the equivalent fractions of 1 by 4, 3 by 5 and 1 by 2 by finding LCM. For that we have to find the LCM of their denominators. So denominators over here are 4, 5 and 2, right? And I'm going to find LCM using this common division method. So 4 and 2 are divided by 2. So 2 2s are 4. 5 I'll note down as it is, and 2 1s are 2. Then we have 2 1s are 2. 5 cannot be divided, so it will be noted down as it is, and then 1. And then we have 5 1s are 5. Right? So the LCM over here will be the multiple of these three numbers. So 2 multiplied by 2 multiplied by 5. 2 2s are 4 and 5 4s are 20. So the LCM of 5, 4 and 2 is 20. So this 20 is the lowest number, which is the multiple of all 4, 5 and 2. So this actually guides us that while writing the equivalent fractions for 1 by 4, 3 by 5 and 1 by 2, we have to make their denominator as 20. Right? So 1 by 2 is there, and if I want to make the denominator as 20, we have to multiply denominator by 20 divided by 2, that is 10. So if I multiply denominator by 10, I have to multiply numerator also by 10. So this will be 1 multiplied by 10 divided by 2 multiplied by 10, and this will be equal to 10 by 20. Right? And here also we have to make denominator as 20. So to make the denominator as 20, we have to multiply 5 by 20 divided by 5. 5 4s are 20. So if I multiply 5 by 4, I am going to get denominator as 20. And since I am multiplying denominator by 4, I have to multiply numerator also by 4, and then we will get the new fraction as 3 4s are 12 and 5 4s are 20. Right? Yes. And here also we have to make denominator as 20. So 4 has to get multiplied by 5. 20 divided by 4 is 5. So when 4 is multiplied by 5, we are going to get 20. And we have to multiply numerator also by 5 to get the equivalent fraction. So we will get 5 1s are 5 and 5 4s are 20. Right? So in this method also we have got same equivalent fractions. For 1 by 4 we have got 5 by 20 as equivalent fraction where the denominator is 20, and for 3 by 5 we have got 12 by 20 where denominator is 20, and for 1 by 2 we have got 10 by 20. Right? And now since we have got all same denominators, the comparison of the numerator will be easy. Right? So 5 by 20 has the least numerator, then we have 10 by 20, and then we have 12 by 20, and their equivalent simplest fractions were 1 by 4, 1 by 2 and 3 by 5. So this is the generalized method where we write equivalent fractions for the given fractions so that their denominators become same. Right? And then we just compare the numerators.